Welcome to Securing Multi-Tier Modern Application Architecture with Volterra platform. This demo is on visibility and observability. In my intro video, I mentioned that you can't protect if you can't see. You can't prevent or mitigate if you don't know what's happening to your apps and where does it interact with. Hence, visibility and observability are more than just an operational tools. In my opinion, it is a foundational component of a better security control. In this video, I'm going to show a couple of visibility and observability that potentially you can leverage Vault Console to give you insight on what's happening to your environment. This is just a few of the screenshots that I captured on the environment where you can have the service graph visibility, the app traffic visibility, as well as the firewall dashboard visibility. Let me log into the Vault Console and show you the real environment. For example, we currently have this BOA webs in my previous video, and currently this BOA webs, what happens that you can go to the HTTP load balancer. You can actually monitor. There's a security monitoring as well as general monitoring. This time around, I'm going to focus on the generic monitoring. If you look at the information that is currently displayed here, there's a lot of useful information from the security perspective. For example, if you look at the this one, like say for example top URL, you will notice that this is /login consists of majority of the connectivity, which is 98.9%. Even though if I show the last 6 hours, potentially there's a lot of activities over time on this application, the BOA webs. You can see that for the past 6 hours, there's a lot of 400s error, as well as some of the errors that you can see that is coming from overseas as well. So let's wait for it to retrieve for the last 6 hours. Alright, so you can see that there's still, although that the last 6 hours, there's still 97.5% of the top URL is called /login. Why there's a so big hit on this /login? The next things probably you can see the traffics, or you can look into the metrics as well. The metrics that look at the trend, what's happening to the things, or you can look at the individual request. From here, you may not be able to see a lot of things because they're combinations of 200. So if you filter off 200, for example, you will notice that there's a lot of 302. 302 means that this is redirect. So probably you can deep dive into what happened to this 302. You can see that from the JSON, you can see that it's actually is hitting the server, as well as you can see that it's actually hitting a lot on the /login. By the way, the reason why, if you look at the dashboard, why there are so many /login, because there's a brute force attack happening at the background. Let's say, for example, if I show you what's happening currently to this application, there's a brute force attack to this username and the login. For this particular application, it is very hard to detect the brute force, because what happens is that when the username and passwords are wrong, this application will redirect to a /login with some message. That's why you see there's a lot of 302 happening on this particular application. This is only one of the examples that you can actually leverage on the monitoring and the visibility and observability to give you further information on what's happening to your application. I can go to the service mesh as well. Here, if I look at this one, potentially here it may not give you much. There's not the same thing. You can look into the request as well. That's where the requests that give you there's a combinations of some of 200 and 300s. So for this particular attack, it is not so obvious because of the response code. So I have the other application probably in HipsterX. This applications is a microservices got distributed across many different environments. So probably the first things that you will notice here, you can see that there's a red color here. Red means it's not good. First of all, you got to ask the questions. you can see that this email services is trying to talk to the payment services and generating a lot of error requests. This, if I click on this link, it gives me an information on some of the health, some of the things that why. By the way, this is zero health, means that there's too many error rate. So probably the question here, why email service need to talk to a payment, right? Because this is a payment service. So what I can do is I can click on the payment service. I can do a explore the service. Once I click the explore service, right, you can see that for this payment service in VoltStack number 2, and checkout service is actually talking to it, which is green, which is good, and email service is talking to it as well. So probably the question is why email service need to talk to a payment service, which by right is only the checkout service. When you want to do the payment, you talk to the payment service. So from here, you can actually derive that something's not right. So you can start to investigate on this line why, or you can look into the request. So from the request, you can see that for the last 1 hour, if I hide the chart, you can see that there's a lot of 500 error. What I mean is that there's an indication that this potentially this email service port potentially got compromised, and what this email service port is trying to do is trying to talk to the payment service. You can see that it's trying to talk to it, and in this case it's actually a simulated, so you can see that it's running a lot of code to the payment service. So from here you can roughly tell, or you can probably derive some of the analytics informations, or some wisdom on what exactly is happening to your application. But even if I go to the HTTP load balancer on that particular general monitoring, I look at that. From here, you may not be able to find much, but you can see from the HTTP error code, there's a lot of HTTP error code. So probably we'll start to ask the questions why there's so many HTTP error code. So HTTP error code, there's potentially two reasons. One, it could be some problem with the application. Two, there's a potential that something is not right, and maybe it's a sign that there's attacks happening. It could be. And the other things that this is just some of tidbits that I can show you that what's happening, and how you can leverage the visibility and the observability of your applications to give you conscious decisions to see whether what exactly is happening to your application. The other things that I want to show you, this is a true story. This is the anatomy of misconfigurations and how Volterra, which I'm using in my environment, detect it. So this is a real one. It's not a makeup, but it's basically it is a misconfigurations on my side rather than the product itself. So the story here is that what happened is that I've been running these environments for quite a while, and I've been doing a lot of research and testings in the environment. So this is the service graph. Basically, this is the forward proxy environment. In this particular namespace, this is the typical normal traffics that I have seen. So what happened is that I have created some of the forward proxy policy and allow anyone to talk to the forward proxy policy. So anyway, all these things sit behind a firewall. So it is only be accessible from within my environment, my lab. So what happened is that one day, without me actually notice that actually I did misconfigurations of the firewall. The misconfigurations of the firewall actually leak out this proxy port to the internet. So initially one day I noticed that how come my service graph shown such a very unusual. Initially it doesn't give me any indication, because anyway this is a lab that I'm using it. In fact, there's a lot of malicious codes running in the lab as well for some research, or even some malware that I've been dissecting in and trying to understand what exactly those malware is happening. So this type of graph, it doesn't really bother me, because I know that this is a sandpit, this is a environment that there's no customer data, it's just like a playground. So which is fine. Then later on, one day after a while, running probably about a few days or maybe about a week, I've noticed that this graph changed significantly. Then I start to notice that there's some heavy traffic, some slowness in my environment. So I start to investigate and try to see how come my lab is actually being connected to so many different IP addresses that without me even noticing. So then and then what happens that eventually I saw this. This is really made me too concerned, because what it is showing me is that actually my box is actually been connecting to a lot of internet nodes. In fact, it took quite a while for this graph to load up, because there's so many type of connectivity. The one that is shown red means that it's actually got a block, and then the green one means accepted. Obviously, because I have did a misconfiguration on the firewall to allow port 317, the proxy port, to be able to access to this box. So that's why I have seen this. So immediately when I see this, I know that I have did some misconfiguration on my firewall. So what I did is that I do a further analysis on the site, on the dashboard. If you notice this value, this one is actually 0.67 terabyte of data received, and my site is actually the top received as well. See, 1.6 terabyte. That is really a lot. So then what happened is that, yep, this is again, it showed me that something's not right. Then later on, another graph as well. Here also show that I'm the top one, and the throughput is a high throughput, and then 1.5 terabyte. So yeah, this is definitely something is not correct, which I immediately investigate and found out that my misconfigurations. I quickly rectified it. But anyway, the damage that it happened here is that basically I'm exposing my forward proxy to the internet, where a lot of people are using it to connect to somewhere else. So what happens that once I eliminate that, before that, just to show you as well that there are 2,818 fails login attempt from someone from internet, which I don't even know where is it from. So this is also shown that that there's a lot of a brute force attack happening in my environment. So yep, once I quickly rectify it, I know that there is a misconfiguration. Then what happens that block this proxy port from on the internet. Then this is back to the normal state, where I have this is more like a normal environment that I'm expecting it. Yeah, is it from this incident, you can see that actually visibility and observability give you a lot of insight that you should have this type of capabilities in your environment to give you an insight on what's happening. So that's why I say that yeah, I mean, if you don't know, you can't protect, by the way, if you can't see. So what I can see now, that my environment is there's a misconfiguration, and obviously you can't prevent or mitigate anything if you don't know what's happening. So with Volterra, it gives you a lot of insight, give you a lot of analytics, it gives you a lot of in-depth information regarding what's happening to your applications, where what's the connectivity point, who is talking to who. Like for example, in this environment, as I mentioned, email service are not supposed to talk to payment. If you see this connectivity, it means that something's wrong with this email service, either misconfigurations on the email service, or potentially this email service got compromised. That's why this email service is trying to attack the payment service. Alright, so basically this is the gist of why visibility, observability, or even analytics is super important, and it should be one of the core components of a better security. Thank you for watching.